When I say projectile motion, what does that mean? What is projectile motion? Physics people? Or non-physics people? Okay, you're going to throw something with velocity. And gravity's acting on it, yes. So here are your two equations for a set of parametric equations that describe projectile motion, okay? So this is describing, okay, x we think of what direction? Horizontal. So the x equation is describing how far our object is going, while the y equation is describing the height of our object. So here we have an opportunity to look at horizontal and vertical movements as our object is being projected through the air. Okay? Now, when we kick, throw, shoot any sort of object, okay, we do so at an angle, all right? So theta is describing the angle that the object is being kicked or thrown, or we'll just say projected from the horizontal, okay? T is obviously going to stand for what? Time in seconds. Okay. V naught is what? Initial velocity. And what we're going to do, I think this model, our velocity is going to be feet per second. Okay. H naught. What does H naught stand for? Initial height. A reminder for those of us, we've all seen this notation before that 0 stands for like time is 0. So the velocity when we begin, the height when we begin. Okay. X will describe the horizontal distance our object is traveling in feet. Y will describe the vertical distance our object is traveling in feet. Okay? So we're going to look at an example together, and we're going to look at a lot of different pieces and talk about how to find each of them. Please keep in mind our X equation is our horizontal movement, our vertical equation, our Y equation is our vertical movement. Okay? If we were to graph this, what would it look like? It would look like a parabola. Very good. A football is kicked with an upward velocity of 30 feet per second. So on your paper, write V naught equals 30 feet per second. At an angle of elevation of 55 degrees. Theta is 55 degrees. Consider the position of the ball at any time t if air resistance doesn't matter. Okay, I want to come back to here. Matt did mention something about gravity. This negative 16, I know you guys don't usually use feet in physics, but the acceleration due to gravity in feet per second squared is negative 32. So that's where the 16 is coming from. It's 1/2 times gravity. Those of you in physics, I wanted to point that out. Okay, so our X equation. Kyler, what would we write?
X equals 30 times cosine of 55
T. And then, what is our y equation?
y equals negative 16 b squared plus 30 times sine 55 and then times t plus what was the initial height again?
What is the initial height? Does it say anything about it being kicked from a certain height? Okay, so we're going to assume that it's being kicked from the ground. So our initial height, we're going to say is plus 0, which we don't have to write. Okay. Now, for fun, I'm going to show you this in the calculator. Okay. So, you actually have, hey, you're going to need your calculator, and you're going to want to make sure it's in degree mode. A lot of yours is going to be in radian mode from our polar. And we can actually graph parametric equations here.
And do we have to change it from polar to?
If you're going to graph this with me, you would need to change it to parametric, but you don't need to graph it. I just want to show you what it looks like. But if you wanted to graph it, you can. Notice how instead of the y equals, we have y equals and x equals together. And when I hit the variable button, it gives me t. It's because we're in parametric mode. Okay? And I'm going to say zoom. Oh, dang it. What happened? That's not what it's supposed to look like. Do you see me type something in there? What is going on? Okay, so maybe I won't show you the graph. Thirty cosine of 55t, negative 16t squared plus 30 sine of 55t. Okay, well, I'll figure out, I'm sure when you leave, I'll figure out what happened in my calculator. Okay, but we have a parabola is what's happening. All right. When will the ball hit the ground? What does that mean?
X is 0.
When x is 0, y is 0. Which one? Okay, if we're talking about any sort of height, we want to consider the y equation. And so if we're going to hit the ground, we want y to be 0. Okay? How do we solve this equation? What? We know we will not eliminate the parameter. We just get to work with algebra. Both terms have a t. Okay, so obviously t equals 0. That's because we begin at the ground. That's not the one that we want. we want negative 16t plus 30 sine of 55 to equal 0. So make sure your calculator is in degree mode and please solve for t. Well, I wouldn't
do PAR instead of
Yeah, but I wouldn't graph it right now. I just want you to use algebra to solve this. Matt asked, is it 1.54? Okay. Okay. It's going to take a little over 1.5 seconds for him to kick the ball, and then it's going to hit the ground again. Those of us who know about football, he's probably not kicking it very far, right? 1.5 seconds, that's not a long time to be in the air. Okay. So let's find out. How far does the ball travel in the horizontal direction? What are we looking for? We're looking for x. And how do we know how far it's traveling in the horizontal direction? Plug in which t? Okay, so we know that from the time he kicks it to the time it hits the ground, it's in the air for 1.54 seconds. So let's go ahead and plug in 1.54 to our x equation. Remember that store feature in your calculator? You can do that with the 1.536 blah, 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 blah. Okay, so you're finding that for me, right? I must have typed something in wrong. Layton has a nice one on his calculator. It worked out fine. I don't know why mine isn't directed right. I'll fix it later. Okay, so how far do we go? Sean, you find it?
I got 26.5.
Like a 9-yard kick.
What?
It's only a 9-yard kick.
Yeah, that wasn't very good. So we're hoping that he was trying to do an onside kick, but it still wasn't a very good one because it has to go 10 yards, doesn't it? Well, I guess not necessarily in the air though. So hopefully it bounced a little bit. No, it does have to go 10 yards in the air, doesn't it?
So, the team needs a new kicker.
The team needs a new kicker. Yes. Okay? Unimportant. At what time will the ball reach its maximum height? From our knowledge of graphs, what feature is the maximum height? The vertex. Okay. Now, we're talking about height, so we want to focus on our y equation. And I'm going to go ahead and rewrite it here. Now, I'm going to go ahead and suggest that you do not complete the square to find the vertex of this parabola, okay? It's not going to go very well, all right? So there is a trick to find the coordinates, in this case, the t-coordinates of the vertex. Does anybody remember that trick? Negative b over 2a will give you the t coordinate of the vertex. Okay, this will help you avoid having to complete the square. We don't want to complete it. Okay, so what do I mean by negative b over 2a? What is b? Did you say 30? Okay, it would also be the sine 55, so you want all of it. The coefficient of t is your b over 2 times
Teachers, please excuse this interruption.
your a.
At this time, will you release all ninth grade students with the last name starting with C?
Your
D,
denominator
or
is
E
2
to
times
help us
negative
for
16.
screening?
Without your calculator, you know that's negative
Last name
32. So when your calculator, put this in as negative 30 sine 55 divided by negative 32. Okay, what do we get? Okay. And based on that, find the maximum height of the football. Kyler.
Can you just divide the total time by 2 and get the?
That is a very good question. Kyler just asked, can we take the total time and cut it in half? To get the time it reaches its maximum height. Why is that okay?
Because it started at 0 and ending at 0.
Okay, if we are starting and ending at the same height, yes, your vertex is going to be smack dab in the middle. What you're going to have to be careful about, though, is if your ball starts like up here, and then you're looking towards the ground. Thank you. Then that's not going to be halfway through. But since they're starting and ending at the same height, yes, that's going to be half of our total time. Okay? Now, how do we find the maximum height of the football? Okay, this is when it reaches its maximum height. Now let's plug it in to find its maximum height. And if you use the store feature in your calculator or the second answer in your calculator, you can get a more accurate answer. Okay. What is the maximum height? Excellent. Okay. What I'm going to do is I'm going to give you this worksheet. Please read through number 1, and we're going to do it together. But I want you to come up with some ideas for how to answer number 1.
Which equation can you give it to us on test?
I don't remember. I will have to let you know. Okay, so read through number 1. first write down our equations. Okay. What is our x equation?
150 times 20.
Okay. And our y equation, someone besides Michaela?
Negative 16t squared plus all the initial sign of theta t plus initial height.
Okay. What's our initial velocity?
Oh, 150. It's not enough. 20.
And what's our initial height?
30.
Okay. So we know that our fence is 20 feet high at a distance of 400 feet away. Correct? How will we determine if this ball goes over the fence? Okay, so keep going with that.
If our y is over 20,
At what moment? At what moment? At what moment does y need to be over 20? 400 feet. So when we are at 400 feet, our y needs to be over 20. How could we determine that? Put what in for x? Okay, so let's figure out when our ball is 400 feet away. Anybody have something for me? 2.84 seconds. That is how long it takes our ball to get 400 feet away from home plate. Then what did we decide we needed to do with that? Okay, let's put that into the y. So when we are 400 feet away, what is our height? .7. Okay, 400 feet away, we're at 19.7 feet. Our fence is 20 feet high. Did this ball go over the fence? It hit the yellow on the top of the fence.
It could bounce over.
Well,
I got 19.9.
Did you say? Like, or did
So
you
did I.
store it?
Yeah.
I think it would like bounce on the top of the fence and jump over.
you think you would bounce and then jump over? We don't have enough evidence to say that that could happen. It is a possibility, but it does not purely go over the fence.
It's good for baseball.
It's a really tall fence.
What is the standard fence?
I don't know, but
I don't know.
that's pretty tall.
It's like,
yeah,
yeah,
right,
right.
reach over.
Yeah.
That's true. That's true. Well, they really don't want people to hit home runs. Okay, before I send you on your way to work on this worksheet, I do want to ask one thing. If we had an initial height right here, we wouldn't be able to factor out a t. How would you be able to solve for t if we had an initial height there? We can only factor if we're set equal to 0. have a quadratic equation. If you have an initial height, the only way to solve that is quadratic formula. Okay? But if you have an initial height of 0, then you can factor in all as well. Right? So your homework is this worksheet. You have time to begin. I expect you to begin. You can get through a majority of number 2 before you leave. One thing I do want you to do at the top, do you see where it says vertex equals? Please change that to t equals negative b over 2a. Since our y function is in terms of t equals negative b over 2a.